Okay, this is 5.2 polynomial functions and their graphs, and this is part 5. So the letter E, or the number E, in mathematics, it is a very specific number. It's sort of like pi. It's irrational, it never ends, it never repeats, and it's a constant. This is a constant that shows up in finance all the time. It will show up in biology and many of the other sciences as well. So it's something to just be aware of. Again, it's a number that never ends, never repeats. It approximates 2.71828. And after that, I'm kind of like, I don't worry too much about it. Sort of like we recognize 3.14159 is close enough for most circumstances. We're not using NASA type stuff at the moment, so it's just fine to use an approximation. Okay, so Euler was the one who came up with this. It doesn't repeat, it doesn't end. And the thing that it's important to know is that you can find it on your calculator. And I'm going to pull that up here just a second. All right, so here we go. Let me quit out of here. All right, so I have an e to the third power. So keep in mind I'm going to have a 2.7 times a 2.7 times a 2.7 something, right? So we're going to have this. I'm going to show you on the e. We have above the ln key, right? We have an e raised to the x power. And the way we're going to get there is we're going to go, we raise it, and then I'm going to put my 3 and close my paren. All right, and so this is going to tell me how to go about doing this. All right, so this gives me 20.0855. All right, and if you stop and think about it, that makes a lot of sense because you've got something somewhere between, you know, close to 3. So 3 times 3 is 9, and then times 3 is going to get you 27. Well, it's not as big as 9. So we know that it's going to be less than that. So this 20 seems like it might actually be pretty reasonable. All right, so when we have this next one, we're going to talk about a negative exponent, which means it's going to be a fraction, and then I have the 0.23, and that's, you've got a fraction and a fraction happening there. So let's go ahead and do the same thing. I'm going to go second, and then right next to my ln, right above the ln, next to the 4, there's my e to the whatever power, and I'm going to say negative 0.23, and that's going to give you 0.7945. And again, this is a little, it's kind of in that ballpark, right? We're expecting it to be about a 3. So, you know, we're talking somewhere around 0.2% of that. So that's going to, that makes sense that that's going to be a smaller number than the than what we would have expected if we had just a 1. Well, this last one, I'm hoping that nobody needs to actually use a calculator for this, because this is e to the 0. And everything raised to the 0, with the exception of 0, is a 1. All right? So I'm going to go ahead and show these off. All right. So that's pretty straightforward. Now, if you wanted to figure out how these things operate, you could also pull it up on your calculator. I will show you really quickly how to do that on your graphing calculator. we are going to do a table set, and that's going to be a second and table. And we're going to start at -3. We're going to go up by 1, right? That delta table is how much are we increasing. So what we have there is we're now going to go to our table. All right, and this is showing us what's going on with our original y. Well, my y, I need to get rid of this. I'm going to clear that off, right? I'm going to clear that off. And we're going to raise that e. We're going to go second, and then e to the x, and close that parentheses. And then on this one, I'm going to go e to the -x. So I'm going to have a second, and then e, and then I'm going to have a negative x, and close that parentheses. And so now we can go ahead and do the table, and you'll see that these two are inverses of one another. Right here I have the 0.4979 with the -3. If I come down here to the +3, it becomes real evident that that's the same number, right? So these two are they're gonna be like reciprocals of each other. And we've been doing a fair amount of that along the way, and I hope I don't have to belabor that. But we've gone ahead and done that. We found numbers. This is the first one, shows us our increasing exponent, and we have an e to the x. That's why it's increasing. Here we have an e to the -x, which is why it's decreasing. We know they're going to cross at 1, 0, 1, right? All right, so here I have an example of what happens when I have my x plus 3. Remember, this is really saying the same as e to the x minus -3. And if you stop and think about what that's saying, is that this is going to affect your x, and this is what's telling you how it's going to behave. So we're going to move this over to the left 3 spaces. Okay, so that will give us the same as our -3 would give us the same as if this is a 0, because I have a -3 plus 3 is going to give me that 0 that I'm looking for. Okay, so here we would have our point, right, where our x is a 0 and our y is a 1. So in this case, it moves it to the left 3 units. Right, before we had it so that this number here was positive, and so we would move it to the right. All right. In this case, I have a negative 0.5x, and so I have a decreasing value. All right, because I'm multiplying. And this is a little tricky, because the previous page I was not multiplying, I was adding or subtracting, right? This is an addition or subtraction happening. So I had to consider what would get me to 0. In this case, if I plug in a 0 here, that's my 0, right? This is a little different. You need to be mindful of what's actually happening inside that quantity. All right? All right, I think we're just about done here. So that's the horizontal stretching. And you're going to have that decreasing, right, because of the negative on that exponent. And here's our next one. I'm going to remind you that this could also be written as minus e to the negative 2x plus 1. Right? So that's going to, this negative flips it over, and then we're going to be approaching the 1. Okay? So the graph is going to get us the shrinking on this. It's going to be a narrower increase. It's going to increase faster than what we had before. And hopefully this is making sense. If you have questions, feel free to contact me or check in your book, and I'm totally happy with helping you out.